Is quantum internet faster than light? Can man transmit data from one point to the next via the internet at incredible speed? This is the question begging for answers, and in this video we will attempt to answer it. Hello and welcome to yet another exciting episode. Today's video will show you how modern science has taken a major step in quantum mechanics and how we may be able to browse the internet at speed much faster than light. So relax and stay focused, as this video promises to be highly informative. Now, we begin. Quantum mechanics is the brainchild of quantum technology, and research into the field has opened up a whole new possibility for opportunities. One of the opportunities that researchers have uncovered is the possibility of ultra-fast communication systems. With fast communication being one of the potential fruits of quantum technology, researchers are now asking the question of whether it can deliver data at a rate much faster than the speed of light. Many experts believe that this is possible if quantum computers are used, because they can solve complex problems that modern computers are unable to solve. This possibility has far-reaching implications for diverse fields such as medical research and even weather prediction. In fact, any field where computers are used will be positively impacted if quantum computers are utilized for the transmission of data. With quantum computers, artificial intelligence will break barriers and become a lot more efficient. Let us also not forget the impact it will have on cybersecurity. However, for all the arguments in favor of the possibility of quantum internet being potentially faster than the speed of light, there still exist many experts who believe that this notion is not true or not feasible. To understand the arguments for and against, let us first review how it works. Advocates of quantum technology put forward the argument of quantum entanglement. Quantum entanglement is tied to the notion of faster-than-light communications. At the foundation of this argument is the phenomenon espoused by Albert Einstein, who described it as a spooky action at a distance. The idea behind it is that entanglement can lead to fast and instant communication. Now, scientists all agree that entangled quantum particles can interact speedily with each other no matter their distance at a rate faster than the speed of light. If this happens, it can lead to a speedy transfer of data at a breathtaking speed. However, with the current knowledge of the inner workings of quantum mechanics, the probability of sending data using this entanglement is impossible. Critics argue that even though particle interaction is possible, it cannot work in real life for communication purposes, because to be able to send quantum data, communication first has to take place, and this is not possible under established parameters. The phenomenon is complicated. The practice of sending data using entanglement may be possible in theory, but it is complex in practice. According to Astronomy magazine, when two particles are inextricably linked together, no matter their separation from one another. Although these entangled particles are not physically connected, they still are able to share information with each other instantaneously, seemingly breaking one of the most hard and fast rules of physics, that no information can be transmitted faster than the speed of light. As you can see from the explanation put forward by Astronomy magazine, while entanglement can lead to faster communication much faster than the speed of light, pulling it off is the hard part. Another argument some scientists have put forward as to why it will not work in practice is that for every scenario where quantum technology is used to send data, there is always a reason why it will not work. The main challenge has to do with the inability of man to forcefully manipulate an entangled particle into a unique state, and how difficult it will be to force the measurement of such a particle to produce an outcome. Manipulating outcomes using particles is difficult, if not impossible, because particles are not random. Furthermore, even in measurements that are correlated, data cannot pass through them, as the receiver and sender can only establish a relationship when they merge later for measurement comparison. So in essence, no information is passed. Nevertheless, scientists continue to research the subject, with many in the physics community believing a quantum internet that is faster than the speed of light is very possible if they get the parameters right. So what is the modern equipment that use quantum technology? For all the difficulties inherent in the idea of using quantum technology for the dissemination of information, what is giving researchers hope is that as of today, there are applications that use this technology one way or the other. Already, some Chinese physicists have measured the speed of quantum technology and recognized the fact that it is indeed faster than light. Also, the possibility of using it for teleportation has been established before now. Furthermore, there are applications applications today that use it, such as quantum cryptography and quantum computing. If scientists are able to produce fiber optic cables that can carry quantum data, then quantum internet will become a possibility. How fast will quantum technology be compared to existing technology? Let's just imagine that quantum entanglement can be used to transfer data. How fast will it be, and in what areas will it improve upon existing technology? Let us do a quick review of existing networks. 5G is the next generation technology that will supplant 4G. Although it is not in full deployment yet, many advanced countries are beginning to test run the technology on a limited scale. The difference between 5G and 4G is that it uses high-frequency millimeter wavelengths. It can operate on frequency bands on an electromagnetic spectrum, and the millimeter waves use 30 to 300 GHz. 5G technology has incredible speed, low latency, and greater bandwidth. The downside to it is that it can only transfer data at short distances, even though it can carry data much faster than 4G. As if we have not seen enough of the wonders of science and technology, researchers are already hard at work on 6G, and based on current progress, many in the industry believe that it will be launched in the next 10 to 15 years. 6G will have a much higher frequency range with a much higher load capacity, but much lower latency level. This technology is expected to transfer data at a rate of 1 terabyte per second, with an unprecedented ability to expand the performance of the modern internet. Although it will be much faster than 5G, however, it will have similar downsides. The principles of quantum internet hold a lot of promise for humankind if scientists are able to make it practical. This technology will allow devices to interact and exchange data via quantum entanglement. While modern computers encode data bit by bit, quantum computers do so in qubits. Qubits are entangled, which makes particles interact regardless of their distance. The ability of quantum computers to send data in qubits will open up the possibility for a much faster and efficient internet. Quantum internet will improve how we communicate in terms of efficiency and capacity. We can see the prospects in several existing applications. For instance, modern algorithms used in cryptography have quantum features used in generating distinct keys. This has made cryptography a sophisticated method that is hard to break or hack. We also see quantum technology at work when it comes to cybersecurity. With the use of encrypted keys, users are able to protect their data and to send data as well. Encrypted keys are difficult to decode or crack. Many believe that quantum internet will be faster than the speed of light, but for this to happen, it will break one rule of physics that has existed for over 100 years. That nothing can be faster than light, absolutely nothing. However, we know that the frontiers of science are largely fluid, and what is impossible today may become possible tomorrow. So even though there are so many limitations of entanglement in practice, the fact that the theory holds some measure of validity will serve as a motivation for researchers to continue to push forward with their findings. More than 2 centuries ago, flying from one part of the world was impossible. But today we have moved away from mundane planes as supersonic planes that travel faster than sound are undergoing tests. If man can fly, nothing is really impossible. Perhaps the late Nelson Mandela was right. It is only impossible because it has not been done yet. If you liked today's video, let us know your thoughts in the comments section below. Don't forget to subscribe and hit the bell to never miss our new videos. Take care.